In this lecture, we're going to learn about stdfunction, and this is a facility we have in C++ to make it easy to work with different types of callbacks that we have seen so far. This facility lives in the functional header, so you need to include this if you need to use stdfunction. And stdfunction is going to abstract away all the kinds of callbacks we have seen before. So we can use this to work with either function pointers, functors, or even lambda functions. As we have seen, we can use all these things as callbacks in our C++ program. So far we have been using function templates to set up functions that could work with any kind of callback. So for example, if we template our modify function on a modifier here, we can really pass any kind of callback here, and the compiler is going to generate a necessary function template instance to make this work. So if we pass in a function pointer, we are going to generate an instance for a function pointer. If we pass in a functor, we are going to generate an instance for the particular functor that we passed in here. And if we pass a lambda function, the compiler is also going to generate a functor, because lambda functions are really represented like functors behind the scenes. So we have been using templates and they could work without a problem, but they have some limitations. And even some people don't like templates because they make code a little bit ugly to read, but I am going to leave that decision to you to decide what you want to use in your code. But even if this is your decision, sometimes templates are going to be limited. And one example I could come up with is, for example, if you want to store your callbacks in a collection like box container. So if we try to do something like this and try to set up a box container of all kinds of callbacks, and we want to be able to store in different kinds of callbacks, we can store in function pointers, we can store in functors, we can store in lambda functions. The problem is going to be what kind of template argument we are going to pass in our angle brackets here, and this is going to be a limitation. And stdfunction offers a solution to this, and we're going to learn about that right now. So to use stdfunction, you use the syntax like what we have here. You say stdfunction, you specify a pair of angle brackets, and inside you specify the signature for the function-like entity this stdfunction object is going to represent. Our function-like entity is going to return a character, and it is going to take input, and you can specify whatever kind of input you want within this pair of parentheses. And in this case, we're going to take a const character by reference n, because we want to use this to do encryption and decryption of characters like we have been doing all along in this chapter here. So once we have this object set up, we're going to give it a variable name, and we can really store any kind of function-like entity in this variable here. In this example, we are going to store in a function pointer, so this might be a function that we have declared somewhere in our code, and we can store the function pointer in here. And once we do that, we can go through our stdfunction object to call our function to encrypt. And this is going to encrypt the character A and print out a D if we get to run this in Visual Studio Code. We can even store it in a functor. So for example, we have a decrypting functor here. We can store it in our stdfunction variable, and we can use our modifier here to decrypt. If we decrypt this D, we will get an A printed out here. We can even store in a lambda function, which is going to encrypt again. So we can set up our lambda function as you see right here, and assign that to our stdfunction object. And this is going to store this in, and we can call our modifier here to encrypt. This is going to encrypt our data. Hopefully this is making some sense. And this is going to abstract away the kind of callback the user uses at runtime when they are using your functions that take callbacks. They have the flexibility to either use function pointers, functors, or even lambda functions, and that's going to be their choice. You will have given them the possibility to use any kind of callback they want in your C++ program. And this is really cool. So this is the basic usage for stdfunction, but we can use this to solve the problem we had before of storing all kinds of crazy kinds of callbacks in a collection like box container here. So what we specify in our angle brackets is going to be an std function, and we are going to specify the return value. We're going to specify the input parameters. Everything is going to work just fine. We are going to give our box container object a variable name, and we can use this to add stuff to our box container object. We can add in a function pointer, we can add in a functor, we can add in a lambda function, and we can loop through this box container using our function-like entities to do stuff. So for example, we can get whatever function-like entity is at a given index, and then we can call that using a character that we pass in here, and we will get the output that corresponds to the particular function-like entity we stored in our collection here, and this is going to work just fine. I realize this may be confusing to many people, especially beginners to these kinds of things, but we will hit Visual Studio Code in a minute and run this, and you're going to see that this is going to work really well. We can even use std function with some of the functions that we have done before. Here we have our modify function, which is going to be modifying a box container of std strings. We are not going to use a callback directly. We're going to take this out, and we're going to model this as std function. This will give us the ability to use any kind of callback we want in our C++ program. We can use a function pointer, we can use a functor, we can use a lambda function. Any of those is really going to work in our C++ program. Here is a simple example of how we could modify our getBest function, which is going to be working on a box container of std strings. We are going to change our callback to be modeled as std function, and we do that like here. We specify the return value, and we're going to specify a bunch of parameters here, and we're going to give this guy a variable name or a parameter name, and we will be using this parameter name in the body of our function to call the callback and get whatever it is we want. This is going to give us the best string based on the kind of callback that we passed in here. So the best string might be decided in terms of size. It might be decided in terms of lexicographical order, as we have seen before. Any of this is really going to work, and you have all this flexibility in your hands now. Now that you know these things, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is std function. I think we can go in and use any lecture that had our box container class. Let's go and see if we can find one. We have one here, so we're going to grab everything from this. If you want, you can grab this box container class from the resource section of this lecture. You're going to have access to these things, and you can use them in your C++ program here. I am going to hop over in our current project and open this in Visual Studio Code so that we can really play with us. This is going to give us our main CPP file, which is going to contain a bunch of things that we don't really need here. I am going to clean this up so that we have a clean starting point. Let's remove everything here in the main function. And we will hop over on top here and set up a bunch of callback functions that we can use. We have one set up as a function pointer. We have one set up as a functor. This is going to have our function call operator, which is going to decrypt because we are subtracting here. You already know this. Now we want to see how we can use std function objects to store all these kinds of crazy callbacks we have in our C++ program. Because we need to use std function, we will need to include the functional header. So let's do that. And we can go down and set up our first std function object. This is going to be set up like we have on line 25 here. We're going to say std function. And in our pair of angle brackets, we're going to specify the signature of the callback that we want this guy to represent. The return value is going to be on the outside here, and we're going to set up a pair of parentheses. And in this pair of parentheses, we're going to put in one or more parameters that this function here is going to be working on. Once we have this std function object called my modifier, we can really store in anything. We will start by storing in a function pointer, and we will store in our encrypt function that we have on top here. This is going to work just fine. Once we have this guy stored in here, we can use it to use the function that it represents under the hood. So we're going to say my modifier and pass in a, and this is going to return a value which is going to be decided by the mechanics that we do in the body of this function here. In this case, we will be encrypting and returning the result. So this is going to encrypt a and give us a d. If we run this program here, we can pass this through our GCC compiler to see the behavior. The build is going to be good as you see here, so we can bring up a terminal window and we can clear and run rooster. You will see that if we encrypt a, we're going to get a d through our stdfunction object, which is really representing a function pointer at this moment. We can also store in a functor. On top, we have a functor setup, which is called decrypt. We have a class for that here. So we're going to create an object of this, and then we're going to store this functor in our stdfunction object. Notice that the functor here satisfies the output and the input of our stdfunction object. The return value must be a char and the input must be a const char reference. And that's what we have in our decrypt functor here. The return value is a char and the input is a const char reference. You have to get these things to match. If they don't, you will get a bunch of compiler errors because the compiler won't know how to take your function-like entity and store that in this stdfunction object. You can try this out, for example, by changing the return value of decrypt to double. Why not? And if we do that, we will have a problem here. Let's try to build the program and show you that we will get a compiler error. This is going to build probably because the compiler is inserting a bunch of implicit conversions. But let's try and do something like std string here. And if we go down, we will get a problem because the compiler doesn't know how to store this decrypt functor in our stdfunction object because the return values don't match. So these guys have to match. You have to make sure of that. Let's turn this back to be a character because we want this to work. And we will build our program now to get it to work. Let's pass it through our GCC compiler. The build is going to be good. So we can clear and run rooster. And we see that if we decrypt D, we're going to get an A through our functor that is stored in our stdfunction object. And this is really cool. We can even store in a lambda function. So let's go down and do that. We're going to put in a lambda function. We're going to say my modifier equals, and we're going to set up a lambda function that we assign to our stdfunction object. This lambda function is going to encrypt again. So we are going to say that if we encrypt A, we're going to get a D. That's what we're going to print here. And the main message is that we are really able to store any kind of function-like entity we have in our stdfunction object. And this is what it was designed for. Let's try to build again and see if our lambda function is working. The build is going to be good as you see here. So we can clear and run rooster. We're going to see that if we encrypt A, it is going to become a D. And our lambda function is really working. And this is the main purpose of stdfunction. Abstracting away any kind of function-like entity you can store in this object, and you will have the ability to use any kind of these function-like entities in your C++ program. Once we use stdfunction, we will have the ability to store even function-like entities in collections like a box container. Let's go down and put in a separator. We're going to say stdc out and put a bunch of hyphens in here. We're going to go down and put in the code. This is going to create a box container of stdfunction, and the std functions we store in our box container will have to have a return value, which is a character, and an input parameter, which is a const char reference. This is the only requirement here. But what we store in can really be any kind of function-like entity we have learned about. We can store in a function pointer like we see here. We can store in a functor. We can store in a lambda function. Any of these things can be stored in our box container object here. So what we can do is, for example, loop through the box container object and use any kind of function-like entity that is stored at any given index in our box container object here, and everything is going to work just fine. We are going to be passing in a D character to see what we get. So let's try and run this program. Our output is going to show up after this separator here. So we can build this, and we're going to see that the build is good, so we can clear and run rooster. We will see that we have a collection of function-like entities. We will add these guys as you see here, and let's see what we get. We will have D as an input. So let's try and put in a bunch of characters here to really make this super easy to follow. We have A and B and C and D and E and F and G and H. We can do something like this. So if we pass in a D and encrypt that, we will add 3 and we will do E, F, G. So the output is going to be G if we encrypt D. That's what we see here. If we decrypt D, we will be moving 3 locations backwards. So we will move by 1, 2, and 3, and we will get A as we have here. So if we decrypt D, we will get an A. The second thing in our box container is something that is going to decrypt, and you see that it was what we have here. So the third thing we have is going to encrypt, and you see that it was this lambda function here which was encrypting. So if we encrypt D, we will get a G back, and this is the result that we really expect here. Everything is working, and we are able to store all kinds of crazy function-like entities in a collection like box container, and this is really cool. Another thing we can do is set up a function which is going to be using a callback as stdfunction. We will put in our modify function that we have used on many occasions, but we're going to change our callback to be stdfunction, and nothing else is going to be modified here. Our callback is going to be called modifier, and we will call that in the body of our function to modify our data. Everything is going to work exactly like it did before. So we can go down in our main function and reuse this. So we're going to put in a separator. And we can go down and set up a box container of std strings that we can use. We're going to put in our data, and this is going to be the same thing. The sky is blue, my friend. We are going to print out the initial data in our box container. We're going to encrypt using our encrypt function pointer, and we're going to decrypt using our functor, and this is going to work really well. And notice that the callback is set up as std function. This is really important to see in this example. And any kind of function-like entity can really work here. We can pass in a function pointer, we can pass in a functor, we can even pass in a lambda function. Any of those is going to work just fine. We can build this with our GCC compiler. The build is going to be good as you see here, so we can clear and run rooster. And if we go down, we're going to see that the data is going to be the sky is blue, my friend. This is the initial data. If we encrypt this, we will get this gibberish here. And if we decrypt with our functor, we're going to get the original data back, and this will be the sky is blue, my friend. Everything is really working as it should. We can also go up and modify our getBest function to work with stdfunction as a callback. So we're going to take out the original callback we had before, and we're going to use stdfunction. The return value is going to be bool, and we're going to pass in a bunch of input parameters here. The parameter name is going to be named comparator, and we will use this in the body of our function here. Now that this is in place, the job we have is to set up any kind of function-like entity to work as our callback. So for example, we can set up a regular old function called larger in size, which is going to decide which string is better based on the size. And we can hop over in our main function and try this out. The first thing we do is put in a separator to make this easy to follow on the terminal. And we can set up our code, so let's do that. And we will say that we are getting the best to be able to follow this. We will set up another function-like entity, which is going to be a lambda function here. This is going to be deciding which string is better based on lexicographical order, and we can use these things here. So for example, we can use our larger in size callback. This is going to be a regular function pointer, and on this second example here, we will use a lambda function, which is really a functor, and everything is really going to work well. So we can try to build our code. The build is going to be good as you see here, so we can clear and run rooster. And in our output here, we're going to see that friend is larger in size and the sky is greater lexicographically, and then we're going to destroy our box container objects. Everything is going to work just fine. This is really all I had to share in this lecture, showing you how you can use stdfunction to abstract away any kind of function-like entity you use in your C++ program. You can use stdfunction objects to store function pointers, functors, or even lambda functions, and everything is going to work really well. We are going to stop here in this lecture. In the next one, we will try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.